Next, we're going to talk a little bit about the use of in quantum mechanics of probability and statistics, and in doing so, we're going to lend some interpretation of these quantum mechanical wave functions. So, we're going to try to cover something that we've sort of left in a little bit ambiguous for some time now. We expect that this wave function psi of x and t has something to do with probability. That comes from our understanding of how to interpret the double slit experiment, in which we saw that the only way we could get interference is to interpret within a single electron there being two wave amplitudes, and the connection to probability came when we looked at the case where we were able to decipher which slit an electron went through in a double slit experiment versus the one where we were not able to decipher which slit the electron went through. And we connected a visualization of a realization of the constructive and destructive interference with the fact that there are two amplitudes or two probabilities. Now, in general, this wave function psi is a complex number, and we saw in the Schrödinger equation most general solutions for psi cannot be just sines and cosines. So if this is a complex number, we can't have it be the probability. Instead, we have the notion given to us by Max Born that the probability is actually connected with the absolute value squared, or norm squared, of this wave function. And I'm going to write this out. This the absolute value squared of the wave function times a dx, it gives us the probability of finding a particle somewhere on the x-axis x between the interval x and x plus dx at a given time. Since the wave function can depend on time, this probability can in general depend on time as well. So this is the hypothesis by Born, and it works well with our double slit experiment because when we take an absolute value squared of two interfering terms, we get the square of each term plus we get a cross term, which gives us that constructive and destructive interference pattern. But we'll see over and over again where this absolute value squared works well as an interpretation of probability.